Hello everyone, I'm Ravali, working as an assistant professor in CSC department from Marri Reddy Institute of Technology and Management, Hyderabad. I'm teaching today subject is mobile application development, and today my topic is introduction to Android operating system. So first, what is Android? Android is an open source Linux based operating system and a platform designed for mobile devices, tablets, and smart devices. So, the main key components of this Android are operating system, which is basically built on a Linux kernel system, and where we have middleware, which consists of core services and frameworks. And we have applications of like native applications and third party applications, which we will download, and we have APIs, which are rich sets of libraries for app development. So, what are the characteristics of this Android? Which it is an open source and it is free to use, which supposes multiple device hardware. And we write this Android code in Java or Kotlin programming language. Uh, we have a large ecosystem of developers where we can get help from the others. Uh, and we can find the apps in the Google Play Store, and we can also distribute whatever applications we develop in the Google Play Store. So, what are the advantages and why Android? So, which mean the first main thing is cost benefits, where we don't need a license for manufacturing an Android, and we have a reduced development cost because since it's already free, we have a low cost. Since it's low cost, we can meet the end customers, and which is developer friendly. It is easy to learn and develop, and it has a since it has a larger developer community, and extensive documentation and tutorials are available for us in the online, and it's an open source code which will be available for everyone, and if you want something we can get from the internet. We have a hardware flexibility. It runs on multiple device types like phones, TVs, tablets, watches, and high-end devices, and it supports various manufacturers, for example Samsung, HTC, Motorola, Oppo, Realme, OnePlus, etc. It is adaptable to different hardware configurations. User benefits for this Android are it's customizable home screen apps. We can change our home screen and apps we can adjust in a way we want to be, and it's easy. App installation is easy because we can download it from App Store, Play Store, and we will get regular security updates. So we can update our phone, which is a rich app ecosystem. Next, we have mobile OS evolution, which is a pre-Android era. First era was from 1990s to 2000s. The developers used to write the code in C or C++ for the specific hardware. So each device or manufacturer should have to write a code for that particular device, and they are custom made, and they used to be a limited code because of reusability. Example, Windows Mobile and proprietary OS. And next we got Era 2, which is a platform based approach which was started in early 2000s, where we use Symbian OS image for wider audience. Provided standardized APIs for developers. It still required complex C++ coding, and hardware specific features were difficult to access. Era 3 comes Java based midlets in mid 2000s. We used to have a Java virtual machine, abstracted hardware, which was easier to cross platform development, and it has a limited low level hardware access. The app were like developed like desktop programs on small screens, and it did not have a leverage of mobile features like touch, mobility, and location. And we have filled this gap with an Android, which was started in the modern mobile level, which was from 2007 to present. This started with the iPhone OS and Android, which introduced our Android is introduced true mobile first OS design, which had the touch first UI, moving away from the mini desktop feel. Sensor integration, we had like native access to the GPS, accelerometers, and cameras. We had app stores for standardized distribution and monetization. High level languages, we were shifting from C++ to Objective C Shift and Java or Kotlin. and we had a lightweight runtime optimized for mobiles. And it was an open source collaboration. If you can see the image, see from 1984 we had the first mobile like Motorola, which was specifically designed for it, and then we had started to increase the development to 2002. If you can see, we got a smart tablets. These are the Android versions, which was started from Android 1.1. Alpha, Beta, Cupcake, Donut, Eclairs, Froyo, Gingerbread, Honeycomb, Ice Cream Sandwich, Jelly Bean, Kit Kat, Lollipop, and Marshmallow. And the next we had the Android versions, which you might know from the present seasons like 7.1 Oreo, Oreo Pie 9.0, Android 10, 11 Red Velvet Cake, Snow Cone, Tiramisu, Upside Down Cake, and presently we are running Android version 16. So the history and of Android and founding. It was established as Android Inc. in October 2003. The founders were Andrew Rubin, he is the CEO, and Rich Miner, Nick Sears, and Chris White, which was started at Palo Alto, California. The original vision was to develop this advanced operating system for digital cameras. They pitched to the investors in April 2004, but the market for cameras was too small for ambitions. So the early changes were difficulty in attracting inventors, faced offline eviction, business model needed version revision. So Google acquired an Android platform. In 2005, Google acquired the Android, and the acquisition price was at least $50 million. The key reason because they saw the potential for mobile revolution. The all founders joined Google as a part of the deal, who developed the Android. In 2005 to 27, it was a development phase with a team led by Andy Rubin developed OS-based Linux kernel, named it as an Android, which is an open-ended and flexible adaptable. Google marketed it to handset makers and carriers. The promise was it was flexible, upgradable, and manufacturer-friendly platform. In 2007, the Android platform was launched. And then next, the Google added proprietary applications like Google Maps, Play Store, notifications, Gmails, and released as an open source mobile platform. Made it attractive for both manufacturers and developers, which is called OHA, Open Handset Alliance. Why OHA was needed? In 2007, multiple competing platforms like Symbian, iOS, Windows Mobile, and BlackBerry. They combined a team. Fragmentation created barriers for developers and needed for standardized open mobile system. The formation they established on November 5th, 2007, which was led by Google, and the purpose was to promote open standards for mobile devices. OHA members, there were 80 plus companies in the OHA. The handfare manufacturers like Samsung, Motorola, HTC, Sony Ericsson, LG, and etc. has joined this team. The mobile carriers like T-Mobile, Vodafone, Sprint, Orange have joined this group. Software companies like Intel, Qualcomm, ARM has also joined them. In semiconductors, they use Qualcomm Snapdragon and ARM Holdings. The key benefits are OHA members get free access to Android source code. The open source licensing allows modification and redistribution and eliminates vendor lock-in. Android milestones. In 2008, the first commercial device, which was HTC Dream T-Mobile G1, was announced on September 23rd, 2008. The significance of this was to provide Android could power real devices. The features of this phone were 3.2 inches touchscreen, slide-out QWERTY keyboard, camera, and GPS. And later, in 2009 to 2011, rapid growth was there. The Android 1.5 Cupcake, 2.0 Eclair, 2.2 Froyo releases, multiple manufacturers adopted platform. It was app ecosystem exploded. In 2014 onwards, the market has dominated. The Android surpassed the iOS in global market share and became the world's most used mobile OS, expansion to tablets. And the TV, wearables, and automotive. Current status in the 2025 and plus 2026, there are 3 plus billion active devices of Android, and 99% of the mobile devices run on Android, and the remaining are the iOS. And the continuous innovation in AI and security and privacy. So here we can see the Android architecture, which is layered like a stack. So Android is in structured layers with specific responsibilities. As you can see, we have the bottom Linux kernel, and in the between we have libraries and Android runtime, and we have application framework and applications. And we will go through one by one. First is a Linux kernel layer. The role of this Linux kernel layer is a foundation layer between core OS functionality and responsible is a hardware abstraction. It acts as an interface between software and hardware and provides drivers for camera, display, and audio sensors. It hides hardware complexity from upper layers. And the resource management, process scheduling, and content switching. And the memory management, RAM allocation, and virtual memory. Power management, which is used for battery optimization. Security, user and permission management. We have an isolated process spaces and secure internal process communication. And we have networking stack for Wi-Fi, cellular, Bluetooth, and socket programming support. For device drivers, we have camera, GPS, touchscreen, microphone, accelerometer, gyroscope, battery, display, and audio. Device drivers, camera, touchscreen, microphone, GPS, accelerometer. Next, we have native libraries layer. The role is to provide low-level functionality in C++ used by higher layers. The core libraries include graphic libraries like Skia Graphics Library, which is for handling 2D graphics rendering, and OpenGL for 3D graphics and games, and the Surface Manager is for display, compositing, and management. And for media framework, we have Media Library for audio, video, playback, and recording. The codec support was MP3, AAC, MP4, and H.264 encoding and decoding. The camera interface draw access to the camera hardware and database for storing. We use SQLite 3 lightweight SQL database engine on the device database for apps used for storing context, messages, calendar storage. Next, we had web and security. For the WebKit, we have used rendering engine for web engines and HTML content. We used SSL or TLS security socket layer for encrypted connections. OpenSSL cryptography library. And the runtime support was given by libc, C standard library, zlib completion library, and libdl for dynamic library loader. Why C++? It had a high performance and lower overhead, direct hardware access, efficient memory usage on mobile devices. We have a Dalvik virtual machine, the heart of Android runtime. What is Dalvik? It's a register-based virtual machine. It executes Android bytecodes .dex files, one virtual machine instance per application. It optimized for mobile devices with limited RAM and battery. And the key features were register-based versus stack-based. Unlike Java virtual machine, it used a stack-based running, and Dalvik uses registers. And we need fewer instructions for running and faster execution. It had a lower memory footprint, which was efficient. And then efficient bytecode.dex files. Java.class files compiled into optimized .dex format, and multiple class files lead to single .dex file save spaces. And DX compiler handles optimization. The process isolation. Each app runs in its own Linux process. Separate Dalvik VM per app so it doesn't overlap any other app. If one app crashes, it doesn't affect the others. Improve security and stability. Memory management. Leverages Linux kernel's memory management. Garbage collection optimized for mobile devices, which made it efficient for handling a low memory conditions. The interesting fact of this Dalvik virtual machine is it was named after Dalvik, a town in Iceland, which was written by Dan Bronstein. And we have ART, which is an Android runtime, which is a modern successor, introduced in Android 5.0 from 2014, ahead of time compilation. Instead of just-in-time compilation, we are using in ART. The fastest app startup, better performance, and now it's standard in the modern Android versions. Android runtime core libraries we have. In this, its role is to provide Java-like functionality for Android apps. It's not actually Java virtual machine. Dalvik Art is not an actual virtual machine. It uses Java language syntax and libraries, but runs Custom Android bytecode formats avoids licensing issue with the Oracle Java. The core Android libraries include Java compatible libraries are which were for standardizing Java packages, networking, cryptography, SQL access, and Android specific libraries for activities, services, intents, content providers, resources, UI buttons, layouts, services, animations, camera, sensors, GPS, audio, video playback, networking, HTTP, SQLite, access, phone, SMS services, GPS location services. Why Dalvik instead of Java Virtual Machine? For an optimized for it was optimized for small mobiles. It is fast and power efficient. And it's a direct Android API access. And it has no licensing restrictions and has a better hardware integration. Next, we have application framework layer. Its role is to provide high level services and abstraction for app developers. The key components are Activity Manager, which controls the application lifecycle like create, start, pause, stop, and destroy, which manages backstack of activities and handles task switching and memory optimization and defines how users interact with the apps. And next, the content providers. It shares the data between the applications securely and access to context, calendar, messages, photos are provided, and a query based access with URI scheme content and built in providers like context, media store, and settings are provided. And we have a notification manager which displays the notification in the status bar with push notifications while using another app and user notifications for events and vibrations, sounds, LED lights controls. And next we have resource manager. Manager manages string layouts, drawables, and colors. Supports multiple device configuration. Screen density scaling like LDPA, MDPA are supported. Integrationalization and localization. We have a package manager which we are used for installing and uninstalling, updating applications, and query installed packages and permissions, and it manages the apps based on the signatures and certificates. Next, we have window manager which controls the window creation and layering. It manages display dimensions and handles orientation changes and multi-window support. Next, we have view system. Because of classes so like UI widgets like button, text view, and edit text, and it also has layout managers where we have linear layout, relative layout, and constraint layout, and we have event handling which includes touch, keyboard, and focus, and custom view creation capability. Intent system. Messaging between app components, implicit intents for system connections, call, email, map, and broadcast receivers for system events, and service launching. Next, we have the application layer, the actual application users with the users interact with. The built-in native Android applications are like communication, where the email client, email, Gmail we have, and SMS management, SMS and MMS, and the phone dialer, the call management, contacts, address books, instant messaging using Google, and productivity we have calendars, contacts, tasks, calculator, clocks, alarms, and file manager. We have media and entertainment where we have music player and audio controls, photo gallery, image viewer, camera and audio recording, video player, YouTube, and web information, WebKit based web browsers like Google Maps, Street View, Navigation, Satellite View, Google News, Chrome. And the system we have home screen launcher which will have settings and configuration and system utilities. Next, we have the Google Play Store. It's an official app marketplace where we have Gmail, Google Drive, Photos, Chrome browser, Google Sheets, Docs, and we also have the third-party apps which we are downloaded from this Play Store, and we have 3+ million apps in this like third-party apps. Generally, we download our social media apps like WhatsApp, Facebook, Twitter, Instagram from the which are the third-party apps from the Play Store. We also download the third party apps are also like banking, shopping, and entertainment also comes under third party apps. We have productivity tools and games. The key point is all the apps are built in and third party built in using the same APIs. No distinction in capabilities between system and user apps. Can be replaced or removed by manufacturers. Thank you.